Hello, Christine Halsey here, and we're going to look at questions 5 through 9 for lab 3 for week 1. It says Elvis. I don't know what they're talking about. Those are on campus. Here online we have the Knights Electronic ML2010, and if you look in files, I've downloaded the manual for it, the operating manual. I think our first question was on fixed supplies, and if you look here, we have a -12, a -5, ground, +5, and +12. These are our fixed supplies. Up here you can see the variable knobs for the -18, +18, and the ground for each is in the middle. Okay, the one question about prototyping environment, I'm not exactly sure what they were looking at with that on the Elvis. Here we have our breadboard. We also have a function generator, a ramp generator, pulse generator. Those are all variable as well. The variable power supply we looked at over here was the -18 and +18 with the variable knobs. We have momentary switches, normally open and normally closed contacts. We have TTL pulse switches, high and low, low to high. Level switches, a set of 8 bits. And we also have toggle switches down here, normally open and normally closed contacts. A lot of those you'll use when you get into your digital classes in the future, but know they're there and that you can use it. We also have up here, the speaker connection, so you can hook up your speaker there and listen to different communication circuits we have. I could see how we could hook them up here and use that output along with our circuits to create an input and be able to hear it on the output. This kit really does a lot. The operations manual is probably the best thing because I don't know all of the functions off the top of my head. I've gotten as many of them as I can. So we're going to be looking at connecting 5 volts and ground to our circuit. And the first thing you want to do is measure it and make sure it is what you think it is. So we're going to look at how to use our multimeter to measure the outputs here, and then how to connect them to the breadboard. Okay, so I have my 2 leads here, the black and the ground slot and the red and +5, and I have it hooked up to my meter. For me to get this meter to turn on, I think I'm having battery problems, but to get it to turn on and go to DC, I had to hold down the select button and turn it to the voltage setting. If you notice, on the voltage setting, it has a wavy line and then the straight line on top of it, which is yellow, which corresponds to the select button right here. So in memory, all I had to do was hit select and it would switch to DC. I'm not sure if I'm having problems with my meter, because now when I turned it on, I had to hold down the select button and turn it to voltage, and then it would come on in DC mode. Now here you can see I have run a black wire down to the blue strip on the breadboard, and this goes along this way. The red strip is the one up top, and that one I've hooked my 5 volts to. And this part of the breadboard runs this way, so to make a connection with 2 things, I need them both to meet in this same row. So I'll give you an example here real quick. If I were connecting to power with the resistor and bringing it in, let's see, I put it in a row right here. I'd be row 54. You can see the numbering up top, so you can actually see what row it's in. Then let's say I need to join it with this capacitor and run it to ground. In 1 second here. Then I'm going to put them both in that same line, 54. If I put them side by side, if I put one in 54 and the other one in 55, then they are not making a connection. Here I hope you can see, I'm trying to get it there. They're both connected, not in the same hole, but in that same line, not side by side. Okay, these up here on the power and ground, they run side by side, so I can connect anywhere on that line and I'll have power. I can connect anywhere on the bottom one and I have ground, because that's where I have run those. All right, for bigger circuits in the future, you can actually connect power and ground from there down to this board with jumper wires. You can see how I've jumpered this side together down here, and I have some single pole double throw switches wired into it. Okay, so now I'm going to show you how to make the measurements for the resistance, and I had put a new battery in my meter and it's doing better. Alright, so if you look at the display, and I'm trying to get my shadow out of there so you can see that says 0.99 k ohms. Now this particular resistor is brown, black, red, gold. Since it was reading 0.99 k, that means it's 990 ohms. Alright, this one here, let's see, looks orange, orange, black, gold, which I'd be expecting 33 ohms, and I'm reading 34.7, and you can see there's no K in front of the ohms, so this is just 34.6.7 ohms. Okay, my third resistor, brown, black, yellow, gold, and I'm reading 99.8 k ohm, so 99.8, almost 100 kilo ohms. Okay, here's my fourth one. It is blue, brown, orange. Well, my eyes don't work like they used to. Gold. 68.2 kilo ohms. So that may be a gray. That's why it's looking so funny. That is a gray. And it might have, yeah, this one is a orange, white, orange, gold. And we're looking at 38.7 kilo ohms. Feel free to use those for your resistor values and measurements, and then calculate the percentage difference and tell us if they're in tolerance. Thank you, and let me know if you have any questions.